Hey everyone, today we're going to be talking about factorization or factor strings. So another way to find factors of a number is by using factor trees, factorizations or factor strings, and prime factorization. That's a lot of factors in there, so let's try to kind of narrow this down. So a factor tree is called a factor tree because it kind of looks like it. It starts with a number up at the top and then it branches out into different numbers. So what you do to answer these factor trees is figure out what factors multiply to this number. So an example of this is for the number 60. The number 60, 4 times 15 equals 60. So see how I'm kind of branching out. I'm taking that 60 and I'm breaking it into 4 times 5. But then I can break that down even further by taking my 4 and factoring that by doing 2 times 2. And I can take 15 and I can factor that as well by doing 3 times 5. So I have a factor tree. So this whole thing together is a factor tree. The 60 all the way down creates that little stump of a tree. If you want to put like a little stump after, that's fine too. But we have a factor tree. Factorization or factor strings are going to be the pretty much the multiplication problems that go straight across. So the 4 times 15, that is one factor string. It's a string because it goes like straight across. And then another factor string is right down here, the 2 times 2 times 3 times 5. So in this example, I have 2 factorizations or factor strings. And then our last vocabulary word is prime factorization. Prime factorization are factor strings that only have prime numbers. So again, numbers that do or that only have 1 and the number itself as its factors. So 2 times 2 times 3 times 5 is going to be the factor or the prime factorization of 60. Just to kind of review, factorization or factor strings are a product of numbers, perhaps with some repetition, resulting in the desired number. So an example is 3 times 20 and 2 times 2 times 15 are factorizations of the number 60. So you have a couple of examples. There's not just one factor string for every single number. If the number is a composite, you can have multiple factor strings. Prime factorization is a product of prime numbers resulting in the desired number. So an example is 7 times 7 times 11 times 13. All of those numbers are prime numbers. Is the prime factorization of the number 7007. So when you multiply all these together, you get your original product. Now, how do you find factor strings? Step 1, put the number you want to find in the factor or find the factor of at the top of the tree. So in this example, I have the number 100 and I have it at the top of my tree. Easy peasy. Now we can get some math done. Step 2, find 2 numbers that multiply to equal that number. This is one factorization. Now, there can be multiple examples of how you factor a number. And it's okay. Just do whatever is you're comfortable with. I'm just going to do my first example, which is going to be 2 times 50. Because 2 times 50 is equal to 100. And I have one factorization right there. So one factorization. Wonderful. Let's see if we can do another one. Step 3. Continue to find factorizations by finding 2 other numbers that multiply to the original number. Okay, so we can do that. Instead of 2 times 50, I'm going to do 4 times 25. Hey, look, I have another factorization. I have another way in order to equal 100. Or find two numbers that multiply to equal a number in the previous factorization. So if I wanted to find a different factorization, I can continue with what I did last time. And then try to find all the prime numbers if I want, or I can just go down one step and see if that works. So I can't break down 2 at all. So I'm going to put 2 right where, or right below it. But 50 I can break down. 50, for example, I can break down into 5 and 10. And I have another prime, or another factorization right there. It's not prime yet, but there are multiple possibilities. If I wanted to break down 50 into 2 and 25, I can do that too. Lots of different options. So factorization can go in many different ways. Now, what about that prime factorization? Okay. The prime factorization will always be the longest factorization or factor string. So you might be asked, what is the longest factor string? Always find those prime numbers because the prime numbers are the smallest that it's ever going to get with number-wise, but then all these numbers multiplied together will be your product. So step 1, complete steps 1 and 2 of factorization. Note, it will not matter what factor pair you write as long as it multiplies to the largest number. So step 1 and step 2 in our last set of notes said that we put our number at the top, which I did. And then step 2 is find two numbers that multiply to equal it. So if I go with my original example, and I have 2 times 50, I have completed step 1 of finding the prime factorizations. Well, that seems pretty easy. Let's continue on. At least I hope it's easy. If not, please feel free to ask questions. Step 2. Find factors of each number until only the prime numbers remain. If you can only multiply one in the number, then you are done. Well, that's the definition of prime numbers, so we should be good. So far, we have 2 times 50. Great. So I have my number 2. Well, 2 is already a prime number because 1 times 2, the only thing that's going to equal 2. So I'm going to just carry this down because there's nothing else that I can break it apart into. But 50 I can. As I said before, we can break this down into 2. Oh, no, not 2. To 5 and 10. So this is just like our previous example, but now I'm going to take it that one step further and find that prime factorization. I see that I have the number 5. 5 is already a prime number, so I'm just going to bring it straight down. And now I'm going to break 10 into prime numbers. And 2 prime numbers that go into 10 are going to be 2 and 5. So sometimes you might have to add a few more branches in order to get to the prime numbers. Sometimes it's just very easy to see. Other than that, it really doesn't matter what numbers you start off with up here. You will always get the same prime factorization. And my prime factorization for 100 is 2 times 5 times 2 times 5. When I multiply all of these together, guess what? I'm going to get 100. Because 2 times 5 is 10. 2 times 5 is 10. And 10 times 10 is 100. So I hope this helps. I hope that you feel comfortable with finding your factor trees, your factorization, and your prime factorization. If you have any questions, please let me know.